Hello, everyone. In this video, we will discuss Chapter 10, Polymorphism via inheritance. Okay, so in the first video, we discussed polymorphism via inheritance, and this one is via interface. Okay, let's look at, I wrote this project based on the lecture notes. So if you remember, we have a speaker interface, okay? And this is what an interface looks like, right? It's public, and the keyword is interface, and then we only have two methods for this interface, speaker. And each method does not have a body, it ends with a semicolon. That is an interface method. And remember, these methods are actually abstract methods, okay? Abstract method. But you do not need the abstract keyword because by default, all methods in an interface are abstract. That's why you do not need it. So you have two methods there, and then we implement the dog class, okay? So public class dog implements, that's the keyword, right? Inheritance is extends, and interface is implements. Implement speaker. So when you implement an interface, you must implement all the methods in that interface. See, if you do not do that, you will have this problem. It will say, must implement the inherited abstract method, announce and speak. So that's why you have to implement both methods, okay? So I just did a simple implementation, speak and announce, just a very simple implementation, that's dog, right? And then I implemented this philosopher class, okay? Philosopher implements speaker, so it must have these two methods implemented. And then for philosopher, so when you implement a speaker, when you implement an interface, you can also have other methods other than the methods in the interface. So in philosopher, we have one more method that is not in the speaker interface. So you can do that, just like the inheritance, okay? So now these are the two classes, right? And let's look at the driver, okay? So you can declare a reference variable of an interface. So here is the thing, an interface cannot be instantiated, but it can be declared as a reference variable. So here we are declaring it as a reference variable, right? Named the current. However, you cannot instantiate an interface. So when you say current equals to new speaker, that will not do because you are trying to instantiate an interface. So this is very similar to the abstract class, right? You can declare a reference variable of an abstract class, but you cannot instantiate an abstract class. Why? Because the methods are abstract and you cannot do that. Okay, so this is not okay. You understand that? So here I'm using current to reference a dog object, okay? And so when we do speak, it will be a dog speaking, right? So it says, I am barking, and that's the dog speaking, okay? So what if I change this pointer? Now, so first I ask it to reference a dog. Now I'm asking it to reference a philosopher. So when you speak, what happens? Let's see. I am contemplating. That's the philosopher speaking, right? So it can, because it's a speaker reference, it can reference any child class object. So it can reference a dog, it can reference a philosopher as well. And when during compilation, when you compile, the system looks for speak, that method, in the interface because current is an interface variable. It's the speaker reference variable. When it actually runs, it will look at the actual object current references and go to that class to use that method body, which is philosopher in this case. And this is the late binding at work, once again, okay? Polymorphism at work also. So now let's do these, okay? I'm going to uncomment. So you can also, this is easy to understand, right? Speaker guest is equal to new philosopher and guest speak. So when you, I think this is in the lecture notes, the exercises. So I'm going to, oh no, this is in the lecture notes. Okay, guest speak. So this will speak, this will be the method in the philosopher class, right? And then you let guest reference a dog object, and then this speak will be the dog speaking. So this is the philosopher speaking, this is the dog speaking. The first one is this one, the philosopher speak. So you can use that instance, that reference variable to reference different types of compatible objects. Okay, so a dog is a speaker, a philosopher is a speaker. That's why you can do that. Let's do these two. Okay, now I'm doing special, speaker special equals to new philosopher. This is okay, right? And then we do special dot pontificate. Let's go to the philosopher class. We do have the pontificate method, but it doesn't compile. Why? You may already understand this. You should, because we discussed this extensively in the first video for this chapter. Because special is a speaker reference variable. And when you call pontificate, the system goes to speaker to look for that method. And in speaker, it's nowhere to be seen. It is actually in philosopher. That's why it does not compile. And so to make it compile, because speak special is a philosopher, it's referencing a philosopher object, so you simply cast it into a philosopher. Okay, and make sure you cast it correctly, the paired parentheses. Now it will pontificate. Okay, so this is the pontificate method, right? Philosopher right here. Okay, so that is very similar. It's exactly the same as what we discussed in the first video. Okay, let's look at these. These are the exercises. Okay, you can do this. Declare two reference variables of speaker. The first one is referencing a dog. The second one is referencing a philosopher. And when we say first.speak, that is the dog barking. When we say first equals to second, what does this do? That means first now is referencing what second is referencing, which is a philosopher, right? So first is referencing what second is referencing, and that is the philosopher. And you can see that when we do first speak, this should speak the philosopher language. Let's see. So I am contemplating, that's the philosopher speaking, right? So even here, it is the dog speaking. So that is the dog speaking. And then you say first equals to second, and now first it's referencing a philosopher. Okay. So let's look at this. This is question 2, I think. Okay. So speaker first equals to new dog. Why is this not okay? Because we already have first here. So I'm going to comment that out. Okay, so this is okay. You already know. Philosopher equals second equals to new philosopher. That's okay. So this is a specific class. The speaker, the speaker's child class, not child, but it implements speaker, right? So philosopher second equals to new philosopher. It's its own class. Second dot pontificate. This runs because second is directly a philosopher object reference variable. So it runs. And now we say first equals to second. This is okay because second is a philosopher reference variable and first is a speaker reference variable. So you always ask from the right to the left. You ask, is the right side object the left-hand side object? So is a philosopher a speaker? If yes, then this is a valid statement. But here you cannot say second equals to first. You cannot do that, right? Because a speaker is not always a philosopher. So that is not okay. You cannot assign a more general type to a specific type unless you cast it, and the cast has to be correct. But you can assign a specific type to a more general type. So that's okay. And now when we do first.speak, it's referencing a philosopher object. So it will do the I am contemplating. Let's see. Okay, so that's that. Okay, so now I am going to comment this out and let's look at this. Now. Okay, so this is okay, you know that, and this is okay, you know that, right? And first is equal to second, that's okay, we discussed that already. And second, pontificate, this is okay because second is a philosopher object. So when it compiles, it goes to philosopher to look for that object. When you do first.pontificate, it's not okay. Why? Because first, even though it's assigned to reference a philosopher, second, which is a philosopher, even though it's that, but first it's of a speaker type. And during compilation, it goes to speaker to look for that method, pontificate, and speaker does not have that method. So even though you do this, during compilation, the system looks for the method in the reference type, and the reference type for first is speaker. Okay, that's why it will not compile. Okay, I think that's it, everybody. That's it for this interface. So if you look at it, let me discuss the difference between interface and abstract classes. Okay, so the difference is for an interface, all methods are abstract. You cannot have bodies for any of the methods. That's interface, okay? For an abstract class, you can have non-abstract method, right? You can have non-abstract methods. So that's the difference. Okay, everybody, that's it. I'm going to stop here.